Hello, and welcome to this session on the Autonomous Database Data Studio. And today we're going to look into how Data Studio can help you streamline your analytics. How do we go about simplifying analytics using the Oracle Autonomous Database? Well, there's really four main stages of workflow that I want to talk about today. I understand there could be potentially other stages of workflow that you may have as a business. You may have data science processes, machine learning processes, and of course, we provide lots of tools for those too. But the ones I want to talk about today are, number one, how to discover and understand available data. Now, what I mean by that is any set of data within the business that you can connect to from the Autonomous Database. And I'll show you how the Autonomous Database can help you not only, once you've made a connection, not only discover which data is available to you, but also quickly import that data or the metadata and understand it and unify it with the rest of the data in the Autonomous Database. The second one is that we can integrate data from really any source. And by that, I mean source applications, on-premise databases, other cloud databases, cloud data lake platforms, all sorts of different connected systems. The third thing is that Data Studio can help you analyze your data, both directly using tools that we provide for data analysis, but also it can help you construct reusable data models, which other tools such as Oracle Analytics Cloud and Tableau can use to optimize their query processing and their consistency. And finally, we'll look at how you can share data sets securely with stakeholders, whether those stakeholders are other autonomous databases within your business, autonomous databases perhaps externally to your business, or really other tools that support an open data sharing standard. But you might think, well, actually, that's all very well, but I have data really everywhere. So I have data that's in secure object storage, perhaps that's in AWS or Azure or Google Cloud Platform, and perhaps you may not realize that the Autonomous Database can connect to that data securely and easily, and it can process that data without necessarily having to bring it into the database. So we can query that data, analyze that data, whether it's directly or if we can also feed the data into the database continuously. The Autonomous Database can understand data lake file formats, so big data formats like Parquet, Avro, but also open table formats like Iceberg. And I'll show an example of that in the demo later on. The Data Studio can help you pull in data from data integration sources, data virtualization sources. You can even reuse metadata that already exists in a connected data catalog, such as an AWS Glue catalog. And I'll show you again how to do that in the demonstration. So really, it doesn't matter if your data is distributed widely across the business. You may have multiple clouds in operation. You may have source applications. You probably do. You have other databases. You almost certainly do. We can not only pull in data from those sources, we can also connect and federate data from those sources. And that's an important aspect of putting the Autonomous Database at the center of your data lakehouse. Equally, although we're going to show you the use of Data Studio, which has a lot of capabilities for things like data integration, connected cloud storage via the OCI Object Store, and analytics tools, I'm hoping that you'll understand that Data Studio can still provide a lot of value to you, even if you already have favored tools for any of those things. So, for example, you may be using one of the data integration tools on this slide already, and that might be an enterprise standard, and that's absolutely fine. You may have any of these cloud platforms, perhaps multiple of them, and that's also fine. And you may be using some of these analytics tools, but actually Data Studio can still help you optimize your analytic workflow. And I'm hoping to show you why and how through the demonstration and the session today. So this is what is provided within Data Studio, what Data Studio can do for you. Okay, so we have a built-in data load tool, data transformations, data analysis, data insights, and data sharing, all sitting on top of a connected Data Studio catalog, which will organize and analyze your metadata across not just the Autonomous Database, but any system to which that Autonomous Database is connected. The data load tool, well, I'm going to show some of this in the demonstration. If you look at the screenshot here, we can see that actually it's a very simple UI to use. So it's powered by the underlying DBMS cloud APIs, but it adds important capabilities on top of that. So for example, if you have a connected cloud object storage platform, the load tool will help you load and link and feed data in from that cloud storage And it will do things like automatically determine the correct columns and the data types to use, the file encoding, things like that, that will make the journey much, much easier when you're integrating the database with your data lake. It also adds features like using AI to detect personally identifiable data in case that you want to deselect those columns when you're loading or linking data into the database. Secondly, we provide this data transforms capability, which can integrate, transform, and prepare your data. And data transforms comes with hundreds of connectors to different source systems, whether those are existing databases, cloud platforms like Google BigQuery, applications like Fusion, NetSuite, and Salesforce. And for those, data transforms actually allows you automatic code generation. So it will automatically give you essentially data integration templates that can understand the source data from, for example, Fusion or NetSuite, and already build tables, sensible tables for analytics from that data. And of course, you can change those if you need to. The important thing about data transforms, it's built using the same infrastructure as Oracle Data Integrator. So that means that it scales with the autonomous database itself. If you need its transformations processing to run faster, all you need to do is scale up the autonomous database, and that will scale up and improve the performance of your transformations, because they are all running as SQL on the autonomous database itself. So they can leverage all of that cloud infrastructure and that same investment. You're not pulling the data in through some separate data integration tool at all. So it limits the amount of data movement you need to perform, and it allows you to leverage your existing investment in the important technology that the autonomous database provides. And using it is very simple. So it's a drag and drop user experience. You can see that it has typical ETL, ELT type processing in the screenshot there. So things like data aggregation, joins, filters, distincts, and so forth. But it also provides new sorts of tools for things like preparing data for machine learning and AI, performing text operations on data, and also things like geocoding for spatial operations. All of those capabilities are provided within Transforms, and we are, of course, adding new operators all the time. The next thing is to talk about data analysis. Now, the intention here is not really to replace or supplant an existing analysis tool that you may have already. So you may well be using an analysis tool like Oracle Analytics Cloud, Tableau, Power BI, or perhaps your users are comfortable with spreadsheet tools like Google Sheets and Excel. But what you can do with data analysis is you construct analytic views, which are like business models of your data within the autonomous database itself. So that means an analytic view is constructed of your reporting hierarchies and dimensions, and your measures and calculations, the things that you might want to report on. So whether those are aggregate sales, average sales over time, all those kind of measures can be modeled directly in the database. What's the advantage of doing that? Well, there are two main advantages. The first is that the SQL that's then required by external applications to perform data analysis is much, much simpler. Most queries are operating across several tables. And those tables, the relationships in those tables are known to the analytic view. So the analytic view comprises usually several tables with the hierarchies and reporting dimensions completely known and defined, and the measures completely known and defined. So that means that you're going to get consistent results across your different analytic tools. The SQL is going to be much simpler, and performance is going to be completely optimized because the database already knows the types of query that you might need to run and will optimize automatically for those queries. So that's a really fantastic capability. It allows a more consistent and streamlined analytic process using the power of the autonomous database. The important thing with the data analysis tool is it allows you to construct some of these business models, but also to verify that they're working correctly. So you have inbuilt charting capabilities. And we also provide two different spreadsheet add-ins which dovetail with that analysis capability. So you can chart your data, you can create pivot tables, you can check your data analysis, and then you can share that with Excel and Google Sheets users who don't have to import the data or export the data from the autonomous database. They just download these spreadsheet add-ins, connect to the database, and then they will see the analytic views and any saved or interesting charts that you've created from them. So it's a really easy way to collaborate on data for data analysts and data scientists within the organization without necessarily having to use more complicated tool sets. The next thing is that we have quite a lot of AI capabilities being built into Data Studio. And one example of that is the Data Insights tool. And what that allows you to do is to use either just the tables in the database or the analytic views that you may have created using data analysis. And we just throw essentially insights, AI algorithms and ML algorithms at the data and ask, well, what might be interesting about this data to you? And so it will search for hidden data anomalies, outliers, reporting dimensions and measures that may be particularly out of the norm, such as the example on the screenshot here. And you can then, it gives you a guide to what you might want to look for when you're analyzing data in your tool of choice, or of course in Data Studio itself. And the final thing I wanted to touch on for the main parts of Data Studio is the ability to share data securely. And we'll talk about the two different ways that we can do that. But most importantly, you can share data with any tool that supports the Delta sharing standard, which was originated by Databricks. So, of course, Databricks itself, but also tools like Power BI, or potentially other organizations that are using the autonomous database, which, of course, can consume shares that you may publish. And you retain control over that data sharing process. So you have a full register of any shares that you've created, who they've been shared with. You can unshare them if you want to. You can control when new versions of data are presented to share recipients and notify them whenever those new versions are available. All of that is provided within the data sharing box, if you like. The other thing that's important to understand here is we can also do live data sharing. So if you like, just easy linking of data between different Oracle Autonomous databases in the same tenancy or region. And I'm going to demonstrate how to do that very shortly. And the other thing to understand, and this is a big area of focus for us in development now, we have the Data Studio catalog. Now, the Data Studio catalog started out as really just an extension of the database data dictionary. So a fairly simple thing which allows you to look not just across database assets like tables, views, analytic views, but also any system that's connected to the database, the objects in those systems. So, for example, files that are in connected cloud storage, whether that's AWS S3, Azure, Google Cloud Platform, or OCI Object Storage. If you have an existing data catalog, such as a Glue catalog or an OCI data catalog, we can connect through to that and then understand and use that metadata to access and see what data is available to the user. We can connect to shares. So any data that's been shared with you by another system. And we can also connect to other databases, whether those are autonomous databases or other types of database. So very soon, the data catalog within Data Studio will allow you to mount catalogs from other databases, from cloud stores, from shares, from things like Iceberg. And you can then use the unified metadata within Data Studio to search, discover, and understand that data, even though it's not necessarily in the database itself. It's available to the database. So it's part of your data platform, even if you haven't decided necessarily to pull that data into the database. And that's a really important capability. And of course, with that unified metadata comes the ability to trace data lineage, so to understand where data comes from and also to see where data is going. So for example, if you create an analytic view, you can trace that back to its source tables. You can trace the tables back to for example, their cloud store files. All right, so now I'm going to give you a brief demonstration of how Data Studio can help link to data in AWS, to load data using from a cloud storage, to create a continuous feed of data into the database from cloud storage, all with very, very simple steps. Create a reusable and schedulable data transformation flow, which is going to prepare the data in an optical form for analytics. And then finally, how to share that created fact table securely with other autonomous databases in the region. So here we are in Data Studio on a new autonomous database, so no data available. But I know I have some data in AWS S3, and I have a Glue catalog which has got all the metadata for that data, and I want to reuse that to capture all that data so that my users can query and analyze it directly. So what I'm going to do is I'm going to go into the data load tool and add a connection to the Glue data catalog. So I'm just going to call that connection Glue. The catalog type is AWS Glue. Now all I need is a credential to access that data catalog. So I've set that up already, but it's a simple standard set of AWS credentials. Then I select the region, and the region I need in this case is US West 1. Select that, and that has the catalog assets that I'm interested in. So I'll create that link. Now once that link is created, I can then go into the link dialog and select the data catalog. And I can find the different locations I want. Now I've got about 20 sets of data here, and I'm not totally sure which of these I might want to use in analysis. So I'm going to add all of them. So I'm going to create external tables over all of these data sets. So what this process does is it analyzes the metadata as it exists in Glue, and it makes sure that that maps onto external table definitions in the autonomous database, so that I'm creating a live set of metadata over those files, which users can then query just as if the data was resident in the database. But of course, it means the data can continue to be updated directly on AWS S3, and the users can just query it dynamically. Now this takes a little bit of time to analyze the data and then create all the links, so I'm going to speed that bit up and show you the end result. Okay, so at the end of that process, you can see I have created all of these external tables directly on top of data in AWS Glue, and I can have a look at that data and check that it's linked correctly. So I can click on each of these new external tables, I can preview the data, and I can also check data lineage, so I can check which files they were created from. So I can see I've got a bunch of sales data here. And that's it. All of those data tables are now available to my users to query and analyze. So let's now load some more data into the autonomous database. And in this case, I have some data on OCI cloud storage. All I need to do in this case is paste the URL into the browser window here, and I can see a bunch of available data sets. Now let's just drag over a few that I need. I know I need movie genres, and I need the movie data. And also in here I have a folder with lots and lots of CSV files. Now let's just say I want all of those into a single table. So let's just create a cost sales table with all of those CSV files. I'll just review the settings of that to show you what that does. So we can see we've detected the encoding of each of these of the file, and the column headings are grabbed from the header row, and that all looks fine. I can check the SQL, and I can see that my files are being got from a cost sales folder. So any CSV files in that folder we're going to be assumed to be matching the same format, and those are going to be loaded in. Now that's going to take a little bit of time to run. So again, we'll speed up this process, and I'll just show you the end result. All right, so that load is finished, and that's great because it means I have all of my sales data loaded in, and that ensures I get optimum performance from the database. But I've had a thought. If these sales files are created in an object store landing area, and I'm imagining that more files may come through in further months. So really what I need to do here is continuously feed that data into the database as it's created. Now I can do that in a couple of ways. I can set up the live feed so that it's notification based, so that whenever a new file is added in, it can pull into the database. But perhaps I'll do it in a simple way just to show how that could be done. So I can create a live feed directly from a load job, and that allows me to create a very simple way of pulling in all these files. So I can see the object filter here is cost sales star.csv, which means all of the CSV files in that cost sales folder will continue to come in. Now there are 24 files currently matching the filter, and I can check through the table settings and so forth. and I can preview the data. But most importantly, what I can do is I can either enable that live feed for notification, which, as I say, means there's a URL which is used to check for new files, or I can just schedule it to run however long I want to. So perhaps in this case, I'll just want to run that daily. Okay, so that just means on a daily basis, if any new files are there in the folder, those will be pulled in to my table. Simple as that. So from now on, I know that I get the optimum performance because I have all of the sales data loaded into the database. But as new files arrive in cloud storage, those are going to be pulled into the table for me so that I can analyze the data and I know it's always up to date. So having loaded the data for sales data and customer data from S3 and from object storage, I can now show how we can use transforms to create a typical flow which might create a fact table for analysis. So we're aggregating the sales data here, joining up with the customer table, joining up with movie genres and movie data, because we're going to analyze customer sales data across those different dimensions in a fact table. And this is a data flow that I've constructed to do it, a fairly simple one using drag and drop here. And I could be bringing in data from all sorts of connected sources that Transforms supports, including Fusion, NetSuite, and so on. But in this case, I have the data already, and I just need to transform and prepare it. So having created that data flow, I'm now going to create a schedule to make sure that that data is always up to date. So if I just create a schedule here, I'll call this load sales data, and I'm just going to select that data flow that I've just created and run it on a daily basis at 7 a.m. And that's all I need to do now to ensure that my users always have up-to-date analysis data in the database. All right, so for the last part of the demo, we've created our fact table now. And in this part of the demo, we're going to show an example of how we might securely share that data with external parties. So we'll do this from the catalog. So we'll have a look at the catalog. And the catalog will show, we can look across all sorts of connected sets of data. So we can look at tables, we can look at views, we can look at files on connected cloud storage, tables in other databases, and so forth. But this is the table that we've just loaded. And in this case, we want to share it. So we're going to create a new share. And we're going to call that sales data. And this is sales data aggregated with reporting dimensions. Okay. And in this case, we can share in a number of different ways. We can share version data using object storage, which puts out Parquet files onto a connected cloud storage. Or in this case, what we want to do is just share this data with other autonomous databases in the same region. So in that case, they're going to get direct linked access to this data. So that's our option in this case. And you can see we've got that table added already, Cus Sales Fact. Now I know I don't need to add any of the other tables to this. I only want to share that one table that I've prepared. So that's nice and simple in this case. And now I can either create recipients, or in this case, all I want to do is share to all of the databases in my region. So that's a default option, and I can just create that as a new share. And now I can easily access that data from other connected databases. Okay, great. Well, I'm hoping that you understood from that demonstration that Data Studio provides really useful and really usable tools that can help your business streamline your analytic workflow, reduce your costs, and improve productivity. What did we do during the demo? We linked data from AWS using Glue Data Catalog in really just a few simple steps. We pulled in all of the data available in that data catalog so that it's available to the autonomous database, even though that data is going to continue to be updated dynamically in AWS. We then loaded some more data from OCI object storage and created a continuous feed of data from object storage so that it will always be up to date, even as more data is added. And that's suitable for sort of typical big data operations like transactional data and so forth. We then use data transforms to create a data flow which will refit that data and prepare it for optimal data analysis. And we scheduled that so that we have a fact table that is kept up to date on a daily basis. And then finally, we shared that fact table with other autonomous databases in our region, which means that those other autonomous databases can access that data just as if it were in the database they're working with directly, but with that secure data sharing capability, which is under my governance as an autonomous database user. So to summarize, Data Studio provides pre-integrated, pre-installed tools which give you 360-degree visibility across your data platform, whether that data platform is Oracle or whether it is actually a multi-cloud, multi-application, multi-database environment where you have data all over the place. Autonomous Database can help you make sense of that data. It can unify the metadata across that landscape, and it can very easily pull that data together and generate these reusable views for analysis, which will optimize performance. And it can do so in a way that's really fairly straightforward for your users to get to grips with. And all of that without buying any additional tools or services or software, all with the capabilities of the autonomous database itself. To find out more, please Google Autonomous Database Data Studio or follow the link on the slide. And I'd like to thank you very much for attending this session today and for bearing with me to the end. Thank you.